Good. Okay. I'm going to assume everybody can see this. So, first time presenting on StreamYard. So, good afternoon, everybody, or I guess good afternoon to those on the East Coast. Good evening to those in Europe. It's actually 10 o'clock in the morning. I'm here in what is normally beautiful Sacramento, California, but unfortunately, we're in the middle of an atmospheric river, so it's not quite as pretty outside as it would otherwise be. But thank you for taking the time to join this talk. As TJ said, we're going to talk a little bit about OAuth, OIDC, protecting third-party credentials, and sort of wrap the whole thing in some of the business cases and business use cases that we've seen for this technology. Okay, so to start with, happy Pi Day, 314. I know, I mean, personally, I'm a pecan pie person, although apple here is a pretty close second favorite. Given that we're after lunch, if people want to drop their favorite pies in the hop-in comments, just and in the chat, just to sort of get people warmed up for chatting as we go through. And then a little bit about me before we sort of launch into the meat of the presentation. As TJ said, I've got a diverse background. I originally trained as an aerospace engineer, ended up finding a job out of university as a management consultant, and then through getting a couple of digital consulting practices off the ground during that time, managed to get myself back into engineering and software engineering. And now I'm focused on APIs. So I'm the core API and innovation lead at Marsh McLennan, and been in this role nearly 2 years at this point, being able to spend my time sort of fully focused on APIs. When I'm not working, when I'm not sort of talking about technology, I've got 3 small children. They're 6, 5, and 2 now, and so they keep me pretty busy when I'm not at work. So what are we going to talk about today? We're going to explain the business problem that we're trying to solve, which is protecting third-party credentials when we're working with both vendors and also just across multiple development teams. Discuss a pattern that we call credential abstraction and how that helps us out. Review some of the issues that came up as we developed that pattern and how OAuth and OIDC standards help to solve them. Talk through some of the technical implementation details. Give a few actual examples of what we've done to better protect our environments and use this technology to enable us on the business side, and then share a little bit about what we're doing next. And so let's start off with our business problem. And before we talk about the business problem, it's actually kind of useful to talk about the business that we're in here at Marsh McLennan. So Marsh McLennan is a really big global professional services firm. We do a whole bunch of things to help out other large businesses. So insurance and reinsurance broking, that's everything from your sort of, run-of-the-mill workers' comp and things along those lines, and helping large organizations get that into, all the way to, I think we insured some of the first moon launches and things along those lines. Human resources and benefits consulting. We administer pension plans. We help people sort of put together their health insurance offerings, pension, other sort of benefits related things. And then management consulting, which is the part of the business I began my career in. As an organization, we're over 150 years old. So we've got a lot of legacy technology, not knocking around, including, paper records and things that go back, maybe not the whole 150 years, but pretty far. And so $20 billion in revenue, so it puts us pretty squarely in the middle of the Fortune 500. And Marsh McLennan, right now we have 4 main operating companies. Marsh, which is our insurance broker, Guy Carpenter's our reinsurance broker, Mercer's our HR consulting arm, Oliver Wyman's our management consulting arm. Over that 150 years, there have been lots of other organizations sort of within the holding company, within the bigger corporate guidance. And probably up until about 2010, we kind of operated as a bunch of independent companies under the same umbrella. And in 2020, we actually established a sort of enterprise-wide tech capability for the first time, MMC Tech. And that was really to accelerate and standardize how we're thinking about technology across the business. And why is that important? Well, APIs are at the heart of a lot of what we're trying to do there. And they're at the heart of reuse, which is probably the most important part of our technology strategy. So for a company that is a professional services company, we actually build a lot of software. We build software for ourselves. We build software for our clients. We build them for our clients' employees and our clients' clients. again, across all of those different lines of business. So, for example, we'll build things to help us better, serve clients in each of the industries we're at. We'll build analytic tools for our clients to use as, SaaS offerings or as on-premise offerings to help them better understand some of the risks they're facing or some of the opportunities they're facing in their markets. Because of our sort of human resources components and our pensions management component, we build tools that are used by our clients' employees, in countries, particularly like the UK or Australia, to actually manage their pensions and where their financial investments and their retirements and where they're assigning money. And then increasingly, what we're building for our clients are digital offerings that our clients can use with their own clients. And so, to give a couple of examples, we'll come back to them later. We're working with a big global logistics organization to provide insurance to their third-party drivers, and the way that we're doing that is all through APIs. So as their drivers are signing up, to work with the large organization, when it comes for them to get insurance for their vehicle, we're actually powering the broking APIs behind the scenes that are connecting that client with our insurance carrier clients to bring it all together in the middle. And so doing something at that range means that we need to get pretty good at reusing things, because what we need to do, we only really have time as application engineering teams to solve the unique problems that application has and reuse common things everywhere else that we can. We also, if you're going to do sort of I showed the reuse taxonomy, which is really around things that you build, but then the other end, the ultimate reuse is just don't build it in the first place and reuse other things. And so there's a lot of technology areas that are not core to our business where we partner with SaaS providers. I think we're actually in the sort of low single-digit hundreds, but definitely over 100 SaaS providers. Everybody from sort of Microsoft and DocuSign down to boutique providers in an individual country and individual area to support our work. And this requires some form of shared trust. So, for example, our identity management teams, I think, were over the last couple of years have added somewhere between 100 and 200 SaaS platforms to single sign-on. Moving so we've got one set of authentication credentials across everything. But there are other ways that we interact with those partners that aren't, through an individual user, and so that's where shared credentials and some of the other problems we have start to appear here. And so one particular challenge, and the thing that sort of, I guess, the problem that spurred what we're going to talk about in the rest of this session, is protecting our long-lived credentials when we're working with our vendors. So ideally, we don't want to be sharing long-lived credentials with our vendors. It broadens the attack surface if those credentials get leaked or compromised. And we also sort of put out a whole bunch of misconfiguration or excessive authorization risk out there into the world. If we give a vendor credentials for Microsoft Graph API, we're reliant on every single one of those credentials being configured properly, there's a lot of process that we have to build around that to allow third parties to use those credentials. And so ideally what we want to do instead is find a way for those vendors to work with us without having long-lived credentials to other systems. And that's where we use a pattern that we call credential abstraction to make that happen. TJ, I'm not sure if you can hear me, but if there are any questions, please feel free to either interrupt or chat them through to me, and I'll take them as we go through, as well as at the end. So credential abstraction. So a quick overview graphically, and I'm going to go through all of these pieces, but fundamentally, credential abstraction is about putting a couple of blocks between a calling application on the left and the underlying service on the right. And those two blocks are replacing the authentication to the underlying service with something else, and then putting in something that handles all the validation, or I guess incremental validation, and switching over to service credentials in the middle. And so that's really sort of at its heart how credential abstraction works. So the first piece, authenticating it. So the moment you would put credential abstraction into sort of a call between a calling application and an underlying API, you have to provide an alternative method for callers to authenticate themselves. You're not going to give them credentials to the underlying service. And so typically what we do there, these are by and large service-to-service calls. We use the OAuth client credentials grant to generate short-lived tokens for those calling applications to use. And we'll come back to this in quite a bit more detail later. We then need to validate those application credentials. So the calling application gets its short-lived credentials. It then passes that to the abstraction service. And the abstraction service is responsible for validating these with the issuer before we let things go any further. And one of the best practices we have is wherever possible, we should be making a call back to that credential issuer to make sure those provided credentials are still valid, rather than just validating the token using a signature. So if you work with a provider like Okta, they will sort of give you that there's sort of the two routes you can go down. You can basically validate the token as received, or you can actually introspect back to Okta's own service and say, is this token still valid? And we really try and do that everywhere that it's feasible to make sure that, effectively the calling application has the right to revoke its own credentials if they feel that they need to do so for any reason, because generally if they're doing that, they've got some level of concern that we'd like to be able to respond to. Then sort of, we've got to go and get the service credentials. So the abstraction, one of the things we like to do with the abstraction service is then actually review the request being made to the underlying service. And so this is effectively sort of a little bit of belt and braces, but basically for the calling application, we should effectively say, you are only allowed to call through to the endpoint method combinations that you're given access to. So let's take sort of a fairly simple, to-do tasks app that you would see in a sort of a lot of demos. We may want some calling applications to be able to read details about an individual task as long as they know the task's unique ID number. We may want some calling applications to be able to list tasks and then go and get information for all of those tasks. And we may want some calling applications to actually be able to post their own and update and edit tasks. And we can manage sort of some permissions at that level within the credential abstraction service itself. And the reason we do that is after we've done those checks, that's the point where then we actually take the application credentials out of the mix and replace those for valid credentials with the underlying service. And ideally, wherever possible, those credentials are application specific, and those are tightly scoped. We want that to what we want that application to be able to do. One of the reasons we have this capability within the abstraction service to sort of, effectively lock down permissions at the endpoint method level is we don't always get that from the underlying service. I mentioned sort of for us as an organization, we've got a lot of challenges from a legacy business perspective. In some cases, we don't have that granularity of service accounts, of role-based access control. And so the abstraction service actually gives us the ability to build coarse-grained RBAC into what we're doing in the space in the middle. We then need to actually rewrite the URI. And so at this point, we now have to basically format the call so that it looks like a vanilla call to the underlying service. This might involve adding in a bunch of incremental things. In some cases, we may do, depending on if the underlying service is more sophisticated, this may be the point where, for example, we calculate signatures and add those into the headers. There's all kinds of things we may choose to do, but basically make sure that the underlying service can now receive the call that we're trying to place to it. This is also sort of another method for keeping sensitive information away from your callers. So, for example, if you've got a tenant ID for an underlying SaaS service, if you're doing a rewrite inside of the credential abstraction service, you don't need to share your tenant ID with your callers. They can just call your credential abstraction service and you'll substitute the tenant ID as needed. Any other identifiers, an account number, something that's not actually the authentication credentials, or frankly, just structure of the underlying source. So if you're now going to something internally that's sensitive, maybe it's the your internal hash you call vault, or something where you're providing back information to the vendor, that's calling the calling application, you may not want to, for example, disclose how you store secrets. Just there might be some information there you want to keep secret. Okay. That obviously goes to the underlying service, which is at the end of the far right-hand side of the diagram here, comes back, however it may come back. And now you've got sort of another shot with the abstraction layer to think about how you want to communicate the response. So you can rip out all of these secrets and sensitives that may be coming back in the application. You can make any changes you want to make to sort of the overall message in the payload. And you can handle and mask errors where you want to. So, for example, if the underlying service gives overly verbose error messages, you can replace these or curtail these. If, for example, one of the things that we do fairly frequently is if the error message coming back from the underlying service indicates that something has gone wrong with our abstraction service or something has gone wrong with the way that we've interfaced with the underlying service, we probably want to mask that, give an appropriate sort of 500 response back to the user, and then obviously get ourselves in a position where we can go and fix it. So that's sort of the credential abstraction pattern and the thing that we use to sort of put our third-party credentials behind. And when we started rolling this out for a couple of different projects, obviously we're sort of an API team. While we're mindful of security, we're not the ultimate security reviewers of what we do, and so we have the security review for the what we're planning to do. And one of the questions that sort of came up as security looked through the flow was, they looked at our fairly standard OAuth request. Somebody, I can't remember if we were using, it was probably sort of HTTP basic authentication. We're going to send our credentials to request a token, and we got asked, well, why are you providing your client ID and your client secret in a request? And yes, it's encoded, but it's not encrypted. And I'm like, that's a fair question. That's the way we've always done it. And then there was a little bit of awkward silence, and the sort of the eyes on the other side of the table were sort of, well, could you do it better? Do you actually have to give all of that information out in a request, even if it's only in one call every however many X minutes while you're trying to get the short-lived token that you can then use back and forth? But it was still a bit of an awkward silence. And so we sort of went away from that with from the review saying, well, can we do better? And so obviously what we were using there was OAuth 2, and OAuth is not an authentication standard. There's a lot of memes about this. Even our security team, and the document that we were looking at for that review had the Pulp Fiction meme at the bottom of it. But it does suggest authentication standards to use. It does suggest using basic auth. It does suggest, if your client can't support basic auth, to put the credentials in the body of the message. And over time, this has basically become the ubiquitous way to interface, with an OAuth server. That's the way you provide credentials in order to get, particularly for the client credentials grant. There's obviously, other things have come in over time, Pixie and other things that have, for the sort of user-based flows. And it says directly below this sort of section 2.3.1, if you're going to do this, you have to use TLS. But that introduces, potential vulnerabilities. There's man-in-the-middle attacks. You've got potential even inadvertent logging of that information to a system that can be otherwise compromised. You've got early TLS termination, and therefore there are parts of the calling flow that may not be under TLS. If you use a proxy, especially in our sort of modern work from home world. Again, I'm not hardwired into my office network right now. There's a lot of proxies and other things in the middle that do interesting things with TLS and packet inspection, and so that information is now available in a way that you may not want it to be. And so luckily, there's sort of, OIDC core gives you a way to sort of come to the rescue a little bit here. And that's because it lists out 4 recommended approaches for client authentication. You've got the 2 methods that are in the OAuth standard, which it calls client secret basic, which is HTTP basic authentication in the header, and client secret post, which is putting your credentials in the body of a message. And it's not It doesn't give you any particular recommendation or judgment there, but it does give you two new methods. And those methods are client secret JWT and private key JWT. And neither of those methods, usefully enough for our sort of darkened room security review, require sending your client secret as part of your token request. So let's start with the easy one. So client secret JWT, and this is sort of using a symmetric secret. This is the simpler of the two options. So as with sort of a standard OAuth client credentials patterns, the server still provides clients with a client ID and a secret, but it no longer requires you to provide them in the request. Instead, the OIDC standard gives you a format for a JOT, including the client ID, and then you sign that JOT with a client secret. And so the authentication server still has both those elements, so it can look at the JOT because the JOT's legible and transparent. It can pull out the client ID, use that to look up the client secret on the authentication server side, and then verify the JOT using the client secret, and effectively go through the same loop and return that as successful. It also, you've still got the same sort of protections around expiry types and nonces and things that are inside of that token and therefore inside of the standard to make sure that that JOT is being used properly. But it enables you basically to have that initial communication, not share the secret again. Now, the main downside here is you've still got a shared secret. And so that needs to be passed somehow out of band between the two environments. And in most sets of policies, you're probably going to need to pass that out of band. I've just realized that I'm not showing you the slide I want to be showing you. So there we go. Which means you missed all the memes from earlier. Okay, so private key JOTs. And so this is using asymmetric keys. So in this case, use asymmetric cryptography to protect your request instead. So the calling application has its own key pair, signs that request with a private key, shares the public key to the authentication server, and then the authentication server can use the public key to verify the signature. And the real, the sort of best case, the wonderful best case of this is if the calling application actually can just expose a URL rather than actually sending the key itself, then any updates required to the key pair are shared automatically. So key pairs in general need to be refreshed less than shared secrets. And when it is refreshed, you can just pick it, as long as you're not changing the URL, you can just pick it up from a shared URL and use that instead. One last sort of useful little feature, and we'll come back to where this is used sort of closer to the end of the presentation, is you can actually embed custom claims inside of the auth request. And so it's not so much that the standard says you should do that, it just says that you should. It doesn't prohibit it either. So the line from sort of OIDC core is that the JOT you send may contain other claims, but you must ignore ones that aren't understood. And so a feature that we've sort of built into our authorization server side of this is basically saying that when you configure a calling application alongside the ID and secret, there's then a list of authorized claims. And so when that JOT comes in, if any of those claims that are sort of contained inside the JOT match the authorized list of claims, then we'll actually embed that into the token that's returned, which means it can then be passed on down the stream, and it gives you a verifiable way of getting information into the API. So when we came down to the decision of what are we going to use in order to sort of answer our security question, and therefore get through the next review and improve our sort of security posture, we decided to go with client secret JWT. And the reason was our sort of initial two use cases here were both working with clients. And so when we spoke with our client technology teams, fundamentally, and we'll talk about the implementation now so you can sort of see this, they were sort of understood the need to have greater security here, in particular, given the nature of some of the data that was being passed, and therefore were on board with basically saying we can handle this incremental level of complexity in order to get there. Okay, so let's talk a little bit about the implementation details. So a lot of this we leveraged our API gateway. So Marsh McLennan uses Apisecure Hybrid, and we already have this configured as a sort of our OAuth token issuer for machine-to-machine calls. Downside, Apigee has a lot of standard capabilities built around OAuth. Unfortunately, from an authentication perspective for issuing those tokens, the only things that come with it out of the box were client secret basic and client secret post, sort of the ones that are provided in the OAuth standard. And so in that case, what we decided to do is let's take our existing sort of proxy that's managing OAuth token issuing and enhance it so that it can validate and transform the call into something that Apigee can actually manage. And if you're not familiar with Apigee, this probably just looks like a bunch of colored boxes. But fundamentally, what this shows is, it's an API proxies are pretty similar across different technology vendors. Fundamentally, you're putting in policies in some sort of flow that has some level of conditional flow or branching. In this case, what you've got is basically a pretty linear flow, and we just broke it apart and put a whole bunch of new components in the middle that allowed us to go from a standard OAuth token issuer to an OAuth token issuer that could handle JOTs being provided from, or client secret format JOTs being provided from the standard. And so what are we doing in that space? Simply put, we're saying we've received sort of the request. Let's reach into the body of the request, pull out the JOT and decode it so that we can find the client ID. We then verify the client ID exists within the server to start with. We look up that client secret, and then we use that secret to verify the token signature. And the token signature it's an HMAC 256 signature. I'm pretty sure that's actually as it's stated in the standard. That's what they recommend as the algorithm to use. We keep a cache of the JTI value, the JTI claim, that comes from the token, which is the nonce value. We keep that cache for some multiple of the length of the expiration time of the actual JOTs. So, for example, if we've got, if we have a token that's issued with a 30-minute life or a 5-minute life, whatever it may be, I think we're holding on to that that cache for a few hours basically, so that even if two clients end up regenerating the same thing, if they do it in the same time, they'd have to do it in the same time period for us to cause trouble, and we're using GUIDs and things like that, so we shouldn't have any clashes. We keep that cache. We interrupt the whole flow if that token is not unique. This is Apigee sort of raise fault branch out of the flow thing, and so that actually will fire off that will fire off an error report back to the calling application. And then if it works, what we then do is actually convert our request into basically a client secret post. So we drop those credentials into the body, and then effectively immediately after that, if I go back to here, this same piece of code then kicks in, vacuums them straight back out of the body again, and uses them to keep things going. And all of this is done using sort of basically private variables inside of Apigee. So again, we're trying to keep away from this inadvertent logging. So these are things that are not put out to debug traces, are not logged to the underlying Apigee mechanism. It's all just it's all passed through. Okay. The other thing we did is put together some client libraries. So I think I've got examples, .NET, which we actually built in conjunction with one of our clients, and sort of on the right-hand side, the JavaScript one. There's fundamentally, this was, as you see, it's not that many lines of code. These are sort of 40 lines of code effectively to generate that token versus probably 2 or 3 that you would need for basic authentication. There's common libraries, whether it's in sort of Node.js and that sort of the NPM ecosystem, or Microsoft provided libraries in the .NET ecosystem that do a lot of the heavy lifting here in terms of generating the signatures and generating the tokens. all we have to do is just sort of give people the right configuration and the right things to test to bring it all together. And then just to sort of note on credential abstraction, all the rest of, if that's sort of if we go back to our credential abstraction diagram, sort of 25 slides ago, we saw there were two parts. There was the authentication server, and then the sort of the interface, that the credential abstraction interface that sat between the calling application and the underlying service. We did all of that inside of an API proxy as well, so inside of Apache Hybrid. So it then separately validates the JOT. It sort of calls across to its own authentication service to make sure that it's still valid and it hasn't been revoked. We do all of that, sort of the blocking and tackling around the method and the endpoint that's being requested, substituting the credentials for our underlying service, and then do any rewriting of the URL that's required. So is there anything else I missed in my notes on that I want to share? Okay, so at this point, that's sort of I guess the theory and sort of the abstract implementation. Now let's talk about how we put it all together. So these are sort of the real, and this was actually our sort of precipitating example. This was the thing that got us all started. But fundamentally, we were working with working in Asia Pacific with a healthcare provider, and basically we had a third-party billing provider who needed to be able to send emails and sort of check for replies using Marsh McLennan identity. So somewhere where we outsource something that, in the case of direct client billing, wasn't a core competency of ours, but still wanted to white label everything through sort of the existing user experience that they had. And so in this case, what we did is we put a credentialless facade in front of Microsoft Graph. We used it's now Outlook Online, but Exchange, the sort of the Microsoft email stack, and then use client secret JOT basically to authenticate that request for the OAuth client credentials token. So we worked with our, in this case, the third-party billing provider, in order to basically they reworked the way they interfaced with Graph, and then we gave them the ability to sort of put it all together. Second case, basically almost exact, and this is where we're starting to see common patterns. But the second case, in this case, HR vendor in Europe, so somebody who's solely interfacing with our employees internally, but again wanted the ability to be able to generate emails using Marsh McLennan accounts, have reply tos within Marsh McLennan and all of that. And so again, exactly the same implementation. Put the credential facade in front of Microsoft Graph. Use client secret JOT because again, this is HR data. The previous one was healthcare data, so we want to have sort of these back and forth be as secure as we can. And then use them to authenticate the request for that client credentials token. And then, so both of these are sort of classic credential facade. The third one, actually, this isn't using the credential facade at all, but this is, I spoke a little bit about our B2B2C business at the start. In this case, we have a bank in Europe, and they were building sort of a soup to nuts automotive leasing product. So they were providing the financing, but also providing insurance and working directly with automotive dealers, basically to give their customers sort of a complete online car leasing and acquisition experience, I guess is the best way to describe it. And that meant that there's a lot of things going on inside this application, but one of them was as their customer got to the point where they've selected their vehicle, they've sort of then they need to be able to say, well, now I need to be able, in order to lease it, I need to be able to insure it. And so what we did was we actually implemented that at that point they then need to be able to authenticate to our digital broking platform. But we sort of were then able to leverage this sort of additional feature of the sort of client secret JOT, which was to basically say we could take custom claims in here as well. And so this allowed us basically to take sort of the basic information that we needed about the customer to start the claim, do so in a secure manner, that validated manner. This isn't sensitive information. It's sort of make, model, garaging, zip code, things like that. But it allows us to bring that information across in a verified way that can't be interfered with in any way, that we then transmit downstream to the digital broking platform. So what comes next for us? First thing, frankly, we want to do is bring in the private key JOT method. So That still, to our mind, is the better, the more secure of the two methods. There's no symmetric secret to be shared. There's not, you don't need, there's a lot of things you just don't need to do if you can use that privacy with JOT method. It's effectively configure it once, and from our perspective as sort of the API provider, especially if our client is able to configure it with a URL, we basically don't need to do anything else. They can maintain their own key pair infrastructure, update it as they see fit, and everything will work beautifully. The second thing we want to do is actually move to this being our standard for internal applications. But in order to do that, what we want to do is actually package sort of the full signing infrastructure on top of key vaults. I mean, we use things like AWS, KMS in the cloud. We use HashiCorp Vault on premise. And so we basically want to be able to wrap all of that for developers so that they don't need to understand how each of those platforms work. They just need to give the appropriate configuration so that they can then, and we'll put the right wrappers and SDKs around it, so that they can then send their tokens off for signing, and everything works for that. Yeah. The other thing we'd like to do is create some standardized facades, and sort of you can almost see it, the first one of these jumping out of a couple of the previous slides, but we've still to this point been somewhere where we've got kind of a common approach to solving specific challenges, but we're not really yet reusing it. So we don't have to put a lot of extra thought into the solution in many cases, but actually we still have to put a fair amount of effort in. And so for things like the MS Graph API, as an organization that does make extensive use of Microsoft products, we think we should be able to solve this once for many users and move this toward having sort of a shared facade, shared configuration. So you just onboard a new application to it rather than creating it for each individual use case. And so that's all of the content that sort of wanted to go through. Just a few thanks and acknowledgements at the end of this. A bunch of these are my sort of colleagues and co-workers, so the core API team who I'm privileged to work with every day. So Brian, Hugh, Arushi, Suzanne, and Kambui. We sit underneath the enterprise architecture group here at MMC, and so we're fortunate to have guidance and support from Richard, who heads that organization, and Mike, Jason, and Steve, who sit within it in various levels. Our information security partners, who are phenomenal partners in terms of pushing us to actually think about new things, and sort of when we say this is the way we've always done it, challenges along that. So Mike, Ben, AJ, and Mark. Ray and Thomas, who are the lead architects on the first two projects, who are willing to work with us on this and sort of take the risk for their organization. Gentleman called Jamie Tanner, who I've never met, but has written a couple of blog posts that have ended up sending me in very interesting directions. The one that's referenced here around avoiding client secret was the one that has literally one sentence in there that sent me down the road to build all this together. So thank you to him. He's a software engineer out of the UK. Obviously, the folks here at API Days and Apisecure 2023 for having us. And you've seen all sort of the stock photos that came through here. All of those courtesy of Unsplash. And so clearly a shout out to the content creators who are generating that for us and allowing this to look a little less boring than it otherwise would. At that point, I know this is a little sooner than sort of the core content was meant to wrap up, but TJ, if you're available to jump in and pass some questions my way, happy to answer them if they're out there.
Okay. Talk. A lot of great material there. On behalf of everyone, thank you so much. We do have one question from the question and answer tab. So the question is, how do you deal with third-party authenticator services that might provide different IAL and or AAL?
Ooh, that is a good question, because I think to this point we've basically sidestepped. The short answer is we haven't yet, because we've basically sidestepped third-party authentication here by forcing any of the third-party authentication behind the facade, which means you can then effectively deal with each of those in their, you could deal with each of those effectively independently, and therefore deal with whatever constraints or lack of constraints they put around their method, and then sort of force a single standard method on the front.
Okay.
I'm not sure I've got an answer about how I would, to be honest. That is a good enough question that it's a good enough question that I don't think I can give an answer off the top of my head, I'm afraid.
Okay. Fair enough. Is there an opportunity maybe for people afterwards to connect with you to, maybe you could, or they could email you a question and maybe you could get back to them?
Yeah, absolutely. I'm not sure what details are sort of available to speaker profile, but I'm very happy if my email or something else is available in my speaker profile. I'm happy to respond to things that come my way. Probably, frankly, the one thing I can guarantee that will work is to send me a message on LinkedIn. That will come through, and then I'm happy to sort of respond to anything through there.
Okay, fair enough. That sounds great. So, folks, there you have it. If you want to connect with Ed, just look him up on LinkedIn, and I'm sure he'd be willing to answer all your questions. So, I have a few questions of my own here, Ed. So, in the industry that you're in, I'm sure you see lots of data. Do you find issues primarily crop up in your own sphere of influence or from the supply chains that you are directly and indirectly connected to?
Ooh, that is, so I think here's what I'd say, is I think a lot of the things that I see are most likely mostly in either my own sphere of influence or one team removed. So one of the things about sort of sitting in a team our focus is core APIs. We do a lot of stuff around, core infrastructure. What I would say is a lot of what we see is basically the challenges and issues that sort of development teams across our organization see. I think we get pulled in probably less to what's going on in their broader ecosystems and vendors and supply. I think from a data perspective, sort of a large data perspective, I think that is figuring out how to make that work in sort of an API world is still, I think, one of our biggest challenges, is sort of moving data to be consumed by APIs versus direct pipes.
Okay. Okay. So another question I just kind of formulating when I was listening to your presentation. I'm sure encryption is used for data at rest as well as data in motion, as it is generally used, across this industry. How do you feel quantum computing will impact this, and is your organization prepared for the impact that may have?
To go on. So here is what I have heard, or at least there's a couple of thoughts we've had around this. One is that, as I understand it, and this is where I am not close enough to details, there are certain encryption algorithms that we use today that will be more or less affected, we believe, by sort of the advent of quantum computing. That's sort of piece one, is there's probably something we could be doing around just selecting an algorithm that gives us a little bit more future proofing. The bigger thing, and this is really where APIs come in, and these are discussions that I'm having with our CISO right now, and so again, it's sort of between enterprise architecture and CISO, and the sort of the CISO organization, it's in that nexus, is no matter what the right technology is to deal with the advent of quantum computing, the thing that is going to help us the most when that comes along is having really good abstractions and commonality for encryption. So if we only have to change an encryption algorithm in, let's say, 5 places versus 400, that is going to allow us to sort of although it doesn't narrow our attack surface per se, it greatly increases the ability to fix our attack surface. So we'll take something like Log4j for an example, right? I think every organization had a lot of work to do around Log4j, and at least a fair amount of that was around sort of the cataloging and the understanding what you had where. And so as we think about encryption, one of the things we are really thinking about is encryption as a service. And so if we can move more and more encryption to basically being implemented in a single place, and the details of that encryption being abstracted away from the developer. So your developer should still have the requirements of what encryption is required, but not necessarily the details of which algorithm is done. Sort of, it's another layer on top of don't implement your own encryption algorithms. Then when we're sort of as quantum becomes more and more widely used, we'll be able to take that step up. We'll be able to say, if this is the defense, it's going to be easier to implement the defense. If somebody comes, that's saying there is a defense, and this is where I'm a little out of my depth in knowing, are we going to be completely overwhelmed by what's coming with quantum, or is it something where we may be able to stay, a few steps ahead for a while?
Right. So basically, you can, react as required. Yeah. Okay. Actually, I see another question came in here, so I'll shoot it off to you. It's from the same person, John. It's related to the previous question. Have you used local means to add IAL quality that is not available from the third-party authenticator?
We have not.
Okay. So that's, I think that's pretty much all the questions I see in the chat here, as well as my own. And like you said, the best way to communicate anything further, should it crop up down the road, is to connect with you on LinkedIn.
Yes.
Okay. So I think we're having a few issues with our next presenter. So is there anything further in the chat from anyone? Any burning questions anyone has? You can just throw them up there in the Q&A tab. Here, one more quick question here, Ed. If someone wants to get more information on the topic you presented today, do you have any resources that you'd recommend, like places to, or even keywords to search on Google or another search engine?
I mean, I think I tried to put a few links in the presentation itself, so hopefully these materials are available. But the place I would probably start is the standards themselves. I found that actually I've spent quite a lot of time on a few topics in the last few years, just reading RFCs and reading things that are close, industry standards that are closely associated with the RFCs. And there is just a lot. Once you get past sort of the fact that the language, they're written in a very specific and very particular way that's designed to be very clear, if a little dry. But there's actually a lot of richness and information there to help you solve problems. And so I think if this is a topic you are interested in, I would start out by reading sort of the relevant sections of the OAuth standard. I would look at, some of the things that the extensions that have come later. I would read that part, OIDC core has a lot in there, and it's very terse, and it doesn't give you a lot of details about how to go out and do it. But I find the standards are pretty interesting in terms of making you think about different things. So that would be where I would start. And then, I think that once you get into those things, I think that then sort of gives you your search terms. So you start finding, things that people are, you sort of find people who are writing about those topics and lean into what they're doing. And then, start experimenting with stuff yourself and sort of implementing it within your organization, implementing it within your own projects, and sort of figuring out what works within your organizational culture to sort of strengthen your security posture within. Again, while as a core team, security is built into everything we do, but we're not, I don't report into the CISO. We're not part of the formal information security organization. But, I think learning about security, learning more and figuring out how you can make what you do more secure every day makes a big difference, and sort of I think in many ways can also change the conversation when you are working with security teams to get things out and live on a deadline, or you're trying to do things that are a little more unusual. Totally out of scope for today's conversation, but I think some of the sort of working with a security team on things like this and on a couple of other areas that we're doing is now helping us as we move to becoming more of a cloud first organization. Is we've sort of built as a development team, we've built a kernel of trust and sort of common understanding of these are the things that are going to come with everything that we do, that allow us then to be potentially relax other constraints or experiment with other things that may today be outside of policy to see if we can think of ways to make them secure to the same standard that would allow them to extend the policy.
Okay. And just as a quick follow on to that, like your slideshow today, is it your plan to make that available? Because you mentioned there was some links and a variety of other information.
Yeah, I'll look to make that. The plan is to do that. I don't know what will be being done through Apisecure. Like, I'm not sure if we're actually. I think I've legally given consent for it all to be disseminated to the world. I'm not sure what I generally tend to do, again, coming back to LinkedIn, is I generally tend to sort of link presentations that I give as publications from LinkedIn, and so it should be available there.
Okay. Okay, sounds good. So there is one more follow-up question from John again. It's along the same theme. So it sounds like you just reject any third-party authenticator services that don't meet your IAL and AAL. Can you comment on that, Ed?
I think this may be a question that the answer is possibly yes. I don't know if I can answer the question. I'm sorry. And the reason is when I think about the stuff that by the time it comes to me and we're sort of looking at it, we've got this credential abstraction pattern. We've got our own standards on the front side of it. There is then the vendor piece on the back side of it. And I don't do the review for whether that vendor piece is acceptable to us. So frankly, I'm now very intrigued as to what we actually do is sort of in the midst of that. So maybe it's probably a question that I can pose to actually some of the colleagues who were listed on the last slide about thanks, about what do we do in that space in terms of what I guess I don't decide what we accept. I sort of get told these are the things that we want to abstract away from our other vendors. Therefore, this is what that decision will be ready to be made by the time it gets to me. I know that's probably not a very satisfactory answer, but again, feel free to reach out to me on LinkedIn. Let's connect, and then I will try and learn more, because I'm now intrigued to understand what we're actually doing on that side of things.
Yeah, definitely. I think the best solution for specific questions like that, John, if you're still listening, reach out to Ed on LinkedIn. And this goes pretty much for anyone else who's in this presentation. If you have specific questions that he may not be able to answer at the present time, I'm sure those answers or those questions could be adequately answered in a conversation on LinkedIn. So that's a very good way. So I guess that's the best way to reach out to you in terms of social media.
Yes.
Perfect. Okay, so I think we're like right on time now for our next presenter. There's just a few issues in the back end here with who's going next, but if anybody has any questions, again, feel free to throw them up there in the Q&A, or make them known somewhere in that the text relay there or chat there. Yeah, do you have any last things you'd like to say, Ed? Any last imparting words of wisdom?
Probably not. I think we probably stretched my extensive pseudo wisdom already in terms of what I've shared already. I think it's a very interesting time to be in APIs, especially with the sort of the Chat GPT API coming out last week. I will share one quick, I guess, story to wrap the conversation, and which is I was having a discussion with a colleague yesterday who was we're trying to figure out if a particular technology could do something, and he shared with me a very detailed set of instructions about how it can be done, and I was like, I feel like that menu doesn't have those options, and so I went to the UI, and I was like, I'm sorry, I'm probably being really dense here, but I literally can't find the button. And what he said was, well, I got off ChatGPT. And of course, ChatGPT, not necessarily being bound entirely by fact, had created a very convincing new feature for this application with a very convincing quick start. It was effectively a set of, 1 through 6 or whatever it was. Unfortunately, none of it was true. So he was a little disappointed the application couldn't do what he wanted it to do. And I was very confused for a while. So that's my first real example of ChatGPT lying to me. So we'll see if it does it again.
Yeah, it's pretty interesting what that's going to bring to across the board to all the industries it touches. Okay, Ed, thank you so much for your time on behalf of everyone in attendance. We appreciate your pearls of wisdom and wish you the best. And anybody who's listening still on this presentation, please reach out to Ed via LinkedIn if you wish or have any specific questions. But once again, Ed, thank you so much for your time.
Not a problem at all. My pleasure.